Hello. All right. The topic before us is wave. Okay. So what's a wave? Now, a wave is defined as a disturbance that travels from one part of a medium to another. Okay. It travels from one part of a medium to another. Then what does it do? Okay. It actually transfers energy. Transferring energy. So a wave, once it is being generated in a medium, it will travel from that point where it is generated. Okay. To the other point. To the other point, okay, transferring energy. So now this graph here represents the graph of a wave. Now since this is the source of the wave, okay, so let's say it's a standing water, and of course one part of a standing water was disturbed. What happened? Ripples will be created. So a wave actually move in form of vibration generated from a source, and that vibration move from that source to the other part of the same medium, but the average position of the medium remains constant. Okay, so if you have been asked what does a wave transfer, what a wave transfers is energy. Now look at this, the graph of a wave. As I already said, a graph of the vertical displacement of the wave, okay, then against the time is the horizontal axis. So as the time progresses, the wave actually repeats cycle. So a wave is like a periodic motion that repeats cycle. As you can see here, at this point the wave makes half cycle, and that half cycle at this point, that's a full cycle. So totally this wave have actually made two cycles. Okay, so as time progresses, the number of cycles that the wave actually makes increases. Okay, so it's a periodic motion. Now the point, the point of the maximum displacement of the wave, okay, is what we call the crest of the wave, while the point of the minimum displacement of the wave is known as the trough. Okay, now in this tutorial we're gonna be looking at the basic time, okay, or basic concepts that is used to describe a wave. Basic concept. So I will start. The very first concept I want to discuss is amplitude of the wave. Amplitude of the wave. So amplitude of the wave is measured from the source of the wave, from the source where the wave was generated, or from the origin to the maximum, okay, the vertical distance from the origin, okay, of the wave to the maximum displacement. Now if that doesn't, let me actually draw that from this graph. Okay, from this point to this point is the amplitude. Of course, from this point to this point is also the amplitude, right? And of course it's measured in meters. It's measured in meters. All right, number two, another important concept you need to learn, okay, is what is known as the wavelength of a wave. The symbol for wavelength, we use the symbol, we call it lambda. Now the wavelength of the wave is actually the horizontal distance that that wave actually covers. Okay, the horizontal distance covers horizontal distance covered by the wave as it actually makes one circle. Okay, in one circle. So the horizontal distance you measure as the wave make one circle, as one wavelength. So it simply means that the distance measured from this point to this point, okay, where the wave makes one circle, is the wavelength of the wave. Okay, so let's proceed. The next important term you need to know is the period of the wave, right? And of course the symbol is capital letter T. So the period is the time it takes the wave to complete one cycle. or one oscillation is still the same thing. Time for one cycle is the period of the wave. Okay, so if I have a wave that actually complete one cycle, let's say this is 1 second and this is 2 seconds. Okay, so the period of this wave is gonna be 2 seconds. That time it takes the wave to complete one cycle. Then of course the next time that we need to learn is the frequency of a wave. Frequency by the symbol F. And the frequency of the wave is defined as the number of oscillation that wave completes per unit time. Okay, the number of oscillation the wave makes per unit time. Okay, for example, if the wave was able to make like 20 cycles within 0.02 seconds, they can simply say that okay, the frequency of this wave, okay, is going to be 20 divided by 0.02. All right, so 20 divided by 0.02, what do we have? That should be 1000. Okay, if I'm not mistaken, that should be 1000, or you can confirm that. So the SI unit of frequency is hertz. That's another way of expressing frequency of a wave. All right, as I said, that frequency of a wave is the number of oscillation, okay, covered within a particular time. Now, when a wave actually, the time for one oscillation is known as the period. Okay, so in that case, I can simply say that frequency is going to be equal to one oscillation, okay, then divided by the time of one oscillation, which is period. So frequency of a wave is also given as the reciprocal of its period. Okay, so 1 over capital letter T is also another way of expressing the frequency of a wave. All right, the next time we're going to look at the phase angle or the phase difference. Phase difference or phase angle is still the same thing of a wave. Now, what's the phase of angle? And of course, the symbol for the phase angle of a wave is phi. Okay, now every wave is a circular motion. So some of the wave start from the origin while some doesn't start from the origin. Okay, so the phase angle of a wave is the angular difference between the wave that starts from the origin. Okay, that angular difference that you measure, if that, okay, between the wave that starts from the origin and the one that doesn't start from the origin. So it simply means that if a wave starts from the origin, okay, that means it doesn't have any phase difference. So such wave, this wave, the phase angle of this wave is simply 0 because it starts from the origin. But let's say this is wave A, but compare it to the wave that didn't start from the origin. Okay, but rather I started from after it must have actually gone quarter cycle. All right, this when this wave started. So before it can actually reach the origin, okay, it is just a quarter cycle. So that means the distance from here to here in an angular part, in an angle, okay, is quarter wavelength. Okay, in an angle, of course, you know very well that half of this is half, this 180, half of 180 is 90 degrees. So the first difference of this wave is 90 degrees. And in wave, we don't use degrees, we use radians. Okay, you should always know how to convert from degrees to radians. The reason being that how do we do that? Okay, 2 pi 360 degrees, which of course is a full cycle is 360, and that's 2 pi radians. So if 360 degrees is 2 pi radians, then 180 degrees is gonna be 180 is half of 360, right? That's pi radians, pi rad. So that way now 90 degrees is going to be equal to pi divided by 2. So this particular wave now, the first angle is 90 degrees, which of course in radian is pi all over 2 radians. Pi all over 2 rad. So I hope that is well understood, okay? What of this wave that actually started from the negative, okay? You know very well a wave starts from the negative after it must have actually completed 180 degrees. So this wave, the first angle of this is 180. It started from the negative circle, okay? It started from the beginning of the negative circle. And we have the beginning of the negative circle actually starts after 180 degrees is gone. So the first angle is 180 degrees, okay? So this wave is 180, and of course in radian that's pi radian. Okay, so we will discuss more on this phase angle of the wave subsequently. All right, so now let's actually look at the last term that is used, or the last concept, okay, that is used to describe a wave. That is a wave velocity, v. Okay, so the wave velocity is actually, of course, v. That's a symbol. Is the rate at which the wave actually changes displacement with time. Remember, as the wave goes, okay, it changes displacement, and that horizontal displacement is wavelength, okay? So invariably now, within one period, the wave actually changes displacement of one wavelength. And within 2 periods, okay, then the 2 period 2t, the wave makes another wavelength that's added to what it made before. That's 2 wavelengths. Okay, so invariably now the velocity of the wave by this formula is the rate of change of horizontal displacement, which of course is one wavelength, okay, which actually happens within 1 period. The rate displacement all over time, and we know very well that, okay, I can still factor this into, okay, please pardon me, this 1 all over t, okay, is still the same with this. And already you know very well that the reciprocal of period is the frequency of a wave. 1 all over t is 1 all over capital letter T is the frequency of the wave. So I can simply say that the velocity of the wave is also given as wavelength multiplied by frequency. So please take note of this. So every wave will always have this relationship. Velocity of a wave is given by the wavelength multiplied by the frequency. So take this as a formula. All right, every wave will always have frequency, have velocity, and of course have wavelength. Let's look at a typical example. Let's look at a radio station, okay, that is transmitting at the frequency of 20, okay, let's say 200 kilohertz, at the frequency of 200 kilohertz, and you're being asked to evaluate the wavelength of such radio station. So how do we do that? We apply the formula V is equal to lambda f. Of course, V is the velocity of every radio wave, or every electromagnetic wave will always use the velocity of light. Velocity of light is constant, okay? It's given as 3 times 10 raised to the power of 8 meter per second. So that way, now if I want to get the wavelength is going to be equal to the velocity of light divided by the frequency. Okay, so velocity of light is 3 times 10 raised to the power of 8. then of course divided by the frequency 200 kilohertz. 200 kilohertz is something as 200 times 1000. That's 200,000 hertz. So how do we do this? So this is going to be equal to, of course, 10 raised to power 8 is like 8 zeros. Okay, so I have 1 2 3 4 5. 5 zeros will count to 8 zeros, so I'll have 3 zeros. So 10 divided by 2 is already 1.5. So 1.5 times 3 zeros, and that 3 zeros is 1000. Okay, so when you multiply this, that should give me 1500. So the wavelength is 1500 meters. All right, I hope that is well understood. As we proceed, okay, so the next thing we're gonna need to learn is the classification of wave, and I will do that in the next video. Okay, so see you in the next video. Thank you very much.